power factor improvement. If you have not subscribed the channel yet, kindly subscribe the channel and press the bell icon so that you may get all the notification of the video uploaded. Now coming to the very first method to improve the power factor, that is static capacitor. Static capacitor. As we know that most of the load connected in industry, factories as well as domestic are inductive load that causes the lagging component of current of the load. So if the lagging component of the current increases, it decreases the power factor of the load. So that is why we have to do something that neutralizes that lagging component. So there is a way designed by the engineers and researchers that static capacitor can cause the leading component of the current. As we know that whenever the capacitor is connected, it decreases the voltage and increase the current of the load, so that whenever we are connecting the static capacitor, it neutralizes the lagging component of the current. Static capacitor connected in parallel with the device which is working on low power factor. When static capacitor is connected in parallel, it causes the leading component of the current, which neutralizes the lagging component of the current, approximately or totally. That will define according to the efficiency and the conditions of the efficiency of lagging component. And whenever the leading component of the current increases, it equalizes or eliminates the lagging component of the current of the load. That causes the power factor improvement, because we know that P is equal to VI cos phi. Whenever I is equal to P over V cos phi, so current and voltage, current and power factor are inversely proportional to each other. When the current increases, power factor decreases. When the current decreases, power factor will obviously increase. So whenever the lagging component of the current will decrease or neutralize or eliminates, it causes the improvement in the power factor. And now we are going to discuss that whenever the static capacitor is connected, it often causes the increment angle to be decreased. Let's suppose we have discussed that whenever the angle between voltage and current increases, it causes the decrement in power factor. Static capacitor often decrease the phase angle between voltage and current, that causes the power factor to be improved. So there are so many advantages and disadvantages of static capacitor over other methods of power factor improvement. But we are saying that static capacitor may be installed at vicinity or large places, say in parallel with the induction motors and power transformer of high rating, so that it may neutralizes the lagging component of current drawn by the induction motor or transformer to be neutralized, and the power factor of the induction motor as well as transformer to be increased. And it will give the very much beneficial to the electrical bills and so many other influences. Stability of the system will be improved and devices efficiency will be higher. So now coming to the advantages of static capacitor. In static capacitor there is low number of losses as compared to the other methods. It has no moving part or rotating part, for maintenance is easy. No foundation required for the installation. It is light in weight. That was the advantage of static capacitor. Disadvantages of static capacitor. Its life is small, that is 8 to 10 years. Whenever the load is changing, we have to on and off the static capacitor. That causes the switching surges on the system. If the rated voltage increases, it can damage it. And once the static capacitor damaged or spoiled, its repairment is very costly. It means that if we are going to change the static capacitor, it is not so costly as its repairment. Used on very high load, so it can be damaged. Whenever the static capacitor is connected in parallel with the device that is working on the low power factor, it improves the lagging, it decreases the lagging component by improving the leading component of the current. But one thing should be taken into account that it only improves or eliminates the reactive component of the current, but it does not disturb the active component of the current. And we can say that before and after the improvement of the power factor, active power remains same, but reactive power eliminates. So that is why the unit of static capacitor is nothing but it is kVAR, because it is also known as the reactive power compensator. So that's why kilovolt ampere reactive is the unit of the static capacitor. Now, synchronous condenser for power factor improvement. Whenever the synchronous motor is running on low load and overexcited, it is often called as the synchronous condenser. When the synchronous condenser is connected across voltage supply in parallel, it draws the leading component of the current and works same as a capacitor. And synchronous motor is installed at the large industries to improve the power factor, because whenever the synchronous motor is running on no load or overexcited, it works as a capacitor because it draws the leading component, and that leading component of the current will neutralize the lagging component of the current. So there are also so many advantages and disadvantages of this method over the other method of power factor improvement. The very first advantage of synchronous motor is its life is high, almost 25 years. High reliability is over here. Stepless adjustment of power factor. It means there will be no any steps required to adjust the power factor. It is not affected by the harmonics. There is no effect of harmonics on it. No generation of harmonics over here. Requires low maintenance. Only the maintenance is what bearing, greasing, we can say maintenance is over here. Disadvantages. It is very expensive because maintenance cost is too much expensive. That's why it is used by only the large users. It produces noise. Noise can affect the signals of we can say that intensity and distorted waveform must be over here. And an auxiliary device must be needed with the synchronous motor, because we know that it is not self-starting, so self-starting torque is not over here, and dampings are required to start the synchronous motor, and that is why we can say that self-starting torque is needed. Self-starting torque is not over here, so starting torque will be generated by an auxiliary device. That is the main disadvantage of synchronous condenser. Phase advancer. Phase advancer is generally an AC exciter which is connected on the main shaft of the motor, and it operates with the motor's rotor circuit to eliminate the reactive component of the load current, and we can say that it is used to improve the power factor of the induction motor. We know that when the stator of the induction motor is connected across the three-phase supply, it draws the lagging component of the current which is out of phase 90 degree with the voltage, and that causes the power factor to the very low value. So to increase that power factor, we have to increase the exciting ampere turns of the induction motor, so that neutralize the lagging component or the reactive power drawn by the induction motor to increase the power factor. If we are going to increase the exciting ampere turns by an AC external force, it does not affect on the current going on the stator winding. So that is why this process is called phase advancer. So phase advancer process is generally used to increase the power factor by exciting the ampere turns of the motor. Now the very first advantage, it can be used on the places where synchronous motor is unacceptable. There are so many places where synchronous motor due to noise we cannot install, because the places are so many sensitive places, and the main lagging kVAR component of power or reactive power drawn by the induction motor may be reduces by using the AC external exciting values or exciters which can be supplied towards the supply frequency. Whenever we connect the exciters to the supply, we can increase the ampere turns of the induction motor, and that exciter will be supplied to the slip frequency. So you know that there is a big relation of the slip frequency of the induction motor to the power factor. So if the slip frequency will be maintained, power factor will also be maintained and will be increased because it will increase the magnetizing current, and that will increase the power factor of the load. The main disadvantage of phase advancer is that it does not be used at the motors below 200 HP or 150 kilowatt about. So this is uneconomical to use over there. So this was the advantage. Now going to summarize the power factor topic, that we have discussed the definition of power factor, that how power factor is designed, and what is the causes of power factor, and how power factor is caused by the lightnings, and then we have discussed the power factor improvement, that how power factor is improved by all these three methods, and we have discussed also the advantage and disadvantage of these methods one by one. So that's all about the power factor. Thank you so much.